Hi, everyone. This is Taylor McLeod from ARMI BIOFABUSA. Can you guys hear me? Awesome. I think we're ready to get going. I wanted to introduce myself. I am the Director of Education and Workforce Development Projects and Outreach at ARMI BIOFABUSA, and I'm really, really excited to be here with you guys today. So I have a presentation teed up, and we're going to kind of go through it, and I'm excited to share it with you guys. So we can go ahead and get started. So I know that a lot of stuff that's been going on in the news is very familiar to you guys. There's a lot of stuff on the science of COVID and kind of everything that's been going on. You're probably, not in person at your governor's cup like you would have liked to have been. I know it's a little bit of an odd scenario to be going through school in a little bit of a different way, but let's dig a little bit deeper in understanding what that actually is. So, what are viruses? Viruses are actually microscopic parasites that cannot live or reproduce without a host body, and that host body is you. So, what does that actually mean? Oops, sorry. So, parasites and viruses can't live on their own. They can't live outside the body, and they depend on you in order to continue to survive and live. So the first thing that they do is they get inside of your nasal pathways, they get inside of your mouth, they enter your body in some way, shape, or form. And then once they're in there, they start replicating and they get a large amount of virus mass inside of your body so that it can start to infect you. So, how does it do that? So, by taking over the actions of the host cell inside of your body, the virus is able to use the normal machinery of the cell to make more virus, essentially making a virus factory. So, you guys may be very familiar with the cell cycle and how the cell basically is able to replicate itself and produce more and more cells. That's a function that's going on inside of your body at all times. So, what actually happens is the virus takes over the control of the cell and is able to continuously reproduce more and more virus, but relies on your cells in order to do so. It can happen very quickly. The way that viruses impact your body, the way that they infect you, etc., it happens relatively quickly. Viruses are super diverse and come in different shapes and sizes, and they infect different hosts and are really different from one another. So I gave a picture over here, and this is kind of a cartoon version, but this is kind of true, right? We have some viruses that, look like weird spaceships. We have viruses that look like spheres with little kind of like arms and legs off of each other that allow them to kind of stick onto things. So they come in a lot of different shapes and sizes, and they're found everywhere. Scientists actually estimate that there are 10 to the 31 viruses that exist at any given moment. That's this gigantic number here. That's how many viruses currently exist on the earth. And that's just absolutely mind blowing. The fact that we get sick as, not often as we do is actually pretty amazing. So we take that into consideration. And I think sometimes we take that for a grain of salt. So when a big virus comes into town, like COVID 19, everyone gets a little nervous, right? So, what is COVID 19? COVID 19 stands for Coronavirus Disease 19 and is also known as SARS CoV 2 for Severe Acute Respiratory Syndrome Coronavirus 2, and it was thought to have arisen in October or November of 2019, with the first patient case showing up in early December of 2019 in Wuhan, China. So, what does this actually mean? So, SARS CoV 2 is actually a respiratory infection. So, what it means is it's causing your respiratory system to be under attack by the virus. You'll experience symptoms that are really similar to the common cold. You'll have a stuffy nose, you'll have a cough, you'll have some difficulty breathing, you may have a headache. But the symptoms of COVID are so unique in that they're not a traditional virus and they vary from person to person. And we'll get into that a little bit more too. So, at the time in December of 2019, not recognizing this as COVID 19, doctors in China saw this as a rare case of an influenza or pneumonia like virus where individuals were displaying severe symptoms and, in some cases, even death. They had these patients coming in, they exhibited similar symptoms, but they weren't traditionally found to have any unique, they weren't testing positive for the flu. They weren't showing positive signs of pneumonia. So it was really a head scratcher to these individuals. And, one off viral infections are pretty normal, right? But to have a large number of people that start exhibiting similar symptoms and not being able to nail it down is a bit concerning, especially for the medical community. Not realizing at the time that this virus is very easily spread and transmissible, doctors, hospitals, and individuals that comprise the community didn't take the proper precautions to prevent spread of the virus. So similar to a way that you are now in social distancing, ensuring that you're wearing a mask, washing your hands frequently, sanitizing, maintaining, a distance to others, right? People weren't taking those precautions. And when those precautions aren't taken, it gets really serious and this virus can actually spread really rapidly. So, about 30 days later, after they saw this rise in a case that they couldn't identify in China, December 31st, 2019, the first public announcement in the pandemic was made, and Hong Kong started to take emergency steps as a mysterious pneumonia like virus had infected 27 individuals in Wuhan. So now this is 27 individuals that went to the hospital, were identified as being really sick, had a fever, had a cough, had trouble breathing, had abnormal x-rays of their chest or CAT scans of their chest that showed a buildup of fluid in their lungs. There's a whole different set of things that could be happening here. What they probably didn't know at the time, and what we actually have the advantage of knowing now, is that not everyone displays symptoms. You may know someone that was sick with COVID and got really, really sick. You may also know someone that was exposed to COVID-19, had a positive test, and wasn't sick at all, right? So it's a very unique circumstance. On February 11th, 2020, the virus was finally identified and was given the name SARS-CoV-2 and COVID-19. This was when the virus was finally identified as, a respiratory syndrome virus. This is when we really started to recognize the severity of the issue, right? By February, there were a whole lot of cases that were happening in China, and the other countries surrounding China and really around the world were kind of bracing for impact to see what happened. Unfortunately, by the time we had identified the virus, nearly almost 2 to 3 months after it was additionally identified, um, the virus was already spreading at incredibly rapid rates. And what we didn't realize was that it was already in other countries and spreading across the world. So I want to show you guys this animation, and I think that this is a really cool animation. And if you're ever looking for examples of where to go, how do I learn more about COVID? The most important thing that I can tell you is make sure that you have a reputable source to find the information. So I'm going to go ahead and play this, and I want you to watch the color of the countries play. So this was January 23rd of 2020, and we can see that there were about 1,000-ish plus minus cases in China. But now let's watch what happens. So we start seeing China getting a little bit more severe, and then we see this global spread. And I think what this shows, right, and it'll continue to play through right now, but I think one really interesting thing that this shows is just how connected we all are. There was an article in USA Today that I had read a while ago, and it basically showed how the virus spread in China itself. So, in a way, similar to what we're viewing right now, right? This pandemic just started to go out of control. It was an easily transmissible virus. The viral particles were living in the air. If you breathe them in, you could be exposed to the virus. There were a lot of different things that were involved in the scenario. So you can kind of see how the virus really evolved from just this 27-person case in China to a global pandemic, right? We are now well over millions of cases in the United States and hundreds of thousands of deaths. And this has just become such a severe, circumstance in the United States, which is why you guys are probably either hybrid learning, remote learning, not really able to hang out with your friends as normally as you would have. Sports are really different. Even life outside of school for other people is really different. We've been working completely from home with my current job. It's been really unique. But I think that that's a really good demonstration of kind of the things that are happening over the course of time. So the next thing I want to talk about is where are we now? So what's happening? Yes, you're at home. Yes, you're doing hopefully all the right things that are allowing you to continue to, live your pretty normal, or what is a normal day-to-day life. So you can kind of see in this top left corner here, I have this medical doctor kind of fighting and combating the virus, right? This is one of the first things that we really need to take into consideration. Doctors were really concerned that this wasn't a thing that people were really taking seriously enough. So they started to do a lot of medical research. They started to, understand the virus, try and understand where it came from, understanding how it varies between people. And these are things that we still don't fully understand. These are things that are not well understood. We don't really understand why, if you get the virus, one person gets really sick and one person doesn't. So in this bottom left-hand corner here, you can also see that there's this chest x-ray, this person with a mask, they have the virus. There's some test tubes over here that are filled with different things. There's prescription medications. Right now, we're really just trying to figure out, how do we best treat the virus? So for individuals that present with these symptoms, what do we do with them? Do we put them in an isolation chamber? No, that's not really the right opportunity, right? But when doctors go in to visit patients that may have a suspected coronavirus, they make sure that they're fully covered in protective equipment. And they make sure that they take all the precautions that they can to prevent themselves from the virus. That may be a mask, a face shield, gloves, gowns. It may be one of those things. It may be all of those things. And it's really dependent. You'll notice that, communities kind of shut down, for lack of a better term. You may remember when this virus originally started, we weren't really doing anything. We were really home. We were taking this really seriously, and we were hoping to prevent the transmission of the virus. And how are we doing that? Aside from social distancing, right? We were taking the right precautions to make sure that people were washing their hands. They were always wearing a mask, right? They're disinfecting things properly. But there are other things to take into consideration as well. Some people believe that, in addition to washing hands, wearing masks, being very cleanly around your home, it's important to eat a healthy diet. Those nutrients and vitamins that are found in those really good foods are really beneficial and may help your body combat the virus. Stay hydrated, drink lots of water, make sure that your body, you're not putting your body at risk and susceptible to the virus. So that's a little bit about the virus itself. I want to go in a little bit and talk about ARMI BioFab USA, which is the organization that I work at. Being from New Hampshire, you guys are probably familiar with ARMI. You may have heard the name, and that's great. And if you haven't heard about it yet, I do want to share this video with you. I'm hoping that you guys will be able to hear it. So I'm going to go ahead and see if my video will play. And if not, that's okay, because we can skip right over it. But I'm going to turn my volume up and give this a go.
There are 400,000 people right now on waiting lists for organs. What if you could make lungs, livers, corneas? What if we create a scalable capability to do that? It's unprecedented.
This is about solving problems that will impact every disease.
It's not regenerative medicine that we're trying to create here. It's the manufacturing of replacement human organs.
The bridge really is between the automation and the scientist. To scale it from doing a few things in a lab to doing tens of thousands of tissues per year. And that's really what we're doing.
The idea was that we would gather off-the-shelf technologies and integrate them into a cohesive system that we could do scalable, modular, automated, and closed manufacturing.
All the researchers need a sterile environment. They all need ways to move, measure, control. But scaling it up, if we can solve it once and solve it right, the modular capability.
See if I can get back to where we were. Sorry about that, guys.
Applies to all of them.
The automation line is going to help us to develop consistent products that we can test at the end in a high throughput manner to understand what's critical about that product in order to ensure that the quality of the product is maintained all the way through.
And now we're sitting in a room with the first complete system that you put in a vial of cells at one end, and 45 days from today will come a completely final product ready to implant. And this system, it's nothing but Rockwell automation boxes tying all of this together.
We talked about 140 companies being involved. It is definitely about a team. This is about teamwork, and it's about changing healthcare and how we're going to go forward.
I used to give talks before we had the line. I would always say, I want to manufacture a tissue in this room. And we've made that a reality.
We're trying to build things that cure disease, not just treat symptoms.
We're going to solve a healthcare problem, which is the largest single problem, both economically this country faces and in terms of quality of life.
So it may just be the science nerd. Ooh, let me see if I can get out of that and go back to my. There we go. It may just be the science nerd in me, but I absolutely love that video, and it truly gets me inspired every time I watch it, because what we're doing is so revolutionary and so next level. We're really, taking things to the next level. So who is ARMI? Well, ARMI BioFab USA is a nonprofit organization, but we're not necessarily doing the science. We're not doing the engineering. We're not doing the automation. ARMI BioFab USA is an aggregation of member companies. We have about 170 members, and you can kind of see them over here in the kidney, who those people are. You may recognize some of these companies, right? We have the Community College System of New Hampshire, Manchester Community College, Great Bay Community College, right? We have some really large universities like UNH, UCLA, Johns Hopkins University, right? There's a lot of different individuals that are involved here. In addition to, the organizations that are university focused, right? We also have some individuals that are from nonprofits. These are advocacy groups, government institutions, standards organizations, nonprofit research institutions, hospitals, clinics. So there are a bunch of members in that space as well that are also part of the ecosystem. And then the largest group of members that we have, about 64%, is comprised of large, small, public-private industry that's determined by the number of employees. So we say large is anything greater than 500, and small would be anything less than that. Now, that's a pretty big range for a small organization, 0 to 500. And there's really, a breakdown there that I want to talk to you guys about. We have member organizations that have just come out of a laboratory with an idea that they want to show us. They have a proof of concept of something that they think is really, really cool, and they want to share that idea with us. And these are literally people that may be working out of their houses, garages, small laboratories. For some people, this is a side job for them, where they're putting all of their extra time and effort that they have into making this practical. But then we do have other companies that are that are still large, but on the small side of things that consist of 100, 200 universities. So I just wanted to focus here. So even though ARMI is the organization itself, what we really are is a consortium, and we bring all of these members together in order to make practical this large scale manufacturing. So I want to talk about that for a second. So what do we do? So ARMI BioFab is a nonprofit organization whose mission is to enable the scalable, consistent, and cost-effective manufacturing of tissues and tissue-related technologies to benefit existing industries and grow new ones. Wow, that's a mouthful. So let's break that down. What does it mean to be scalable? That means that we can take things that are done on a smaller scale and do them easily without much more effort on a much larger scale. You guys may be familiar with that. Consistent. We don't want to grow a piece of skin, a type of cell, an organ that's different from growth cycle to growth cycle to growth cycle. We don't want to grow 6 organs and have them all come out looking differently. We want to make sure that the product that we're manufacturing is consistent and the right product, cost effective. We can't continue to do this process in a manual way in order for it to be cost effective. The beginning of the video, you saw this. There are 400,000 people that are waiting for transplant lists. You guys may or may not be aware, but sometimes the pharmaceuticals that you get at the drugstore right now, if you go to CVS or anything like that, they can be really pricey. So what is the cost of an organ going to be? We hope that by putting this on the market and being able to manufacture these things at large scale is going to drive down the cost and hopefully bring this to more individuals. Tissues. What's a tissue? That's skin, that's cartilage, that's muscle, tendon. It may be more complex tissues like an organ, a kidney, a liver, a cornea, a heart, right? You name it, we're really focused on it. And then tissue-related technologies. What does that mean? Well, there are a lot of things that are necessary in order to make this industry work. We need stuff that's going to measure. We need things that are going to automate the process. So we also are very interested in all of those technologies outside of the science area that are going to help fuel the industry and drive it forward. So we're hoping that we'll be able to benefit those old industries and help grow the new ones. So I kind of debated putting this figure in here that you're looking at right now, and I just want to explain it because what we're doing is really important. So there's down here on this bottom line, it says engineered tissue product development, and it goes from basic research all the way to the demonstration of production scaling. And you can see that the level of funding in your early stages, when you're doing the basic research, the proof of concept, is pretty good. It's pretty easy to find those funds. And then fast forward to the other side of things where you have capability in a production environment, you have production scaling, you're basically able to just punch widgets and get this stuff out. That's also a really well-funded area, and industry's doing a really good job at manufacturing things in that space. But inside, there's this gap, and we commonly refer to this gap as the valley of death. And we call it that because that's basically where technologies don't make it, right? There's no funding opportunities where you have this really cool idea and you want to get it in front of industry so that it can start being scaled. And that's where ARMI comes to the table. We help companies realize that there can be fabrication in a laboratory. We help them produce their original prototype. We help them think about the large scale manufacturing. And that's really our focus area and what we do. So all of this is great, right? ARMI is cool. We're, very science focused. We require engineers, chemists, biologists, automation specialists, robotic specialists. We need everyone in order to make this happen. But how does this relate to COVID-19? Well, let me try and explain it to you a little bit. So what you saw in that video was our tissue foundry. So what this does is, and Dean came and said it at the beginning of the video, you basically put in a vial of cells, and they may be your cells to create you an organ, or they may be from a donor and help create an organ that will go inside of your body. So they take that cell, they grow it up, they gather it, they build a scaffold, put the scaffold and the cells together to make a tissue, package and preserve it, and then send it off to the patient. And all of this is well and good, but what we have to think about is why this may be important. What does organ manufacturing have to do with COVID? Some things that you guys may have heard about and maybe not. So maybe this may be new information to you. There's potential if you get very sick from COVID to have long-term effects. They're very worried about lung infection in individuals with COVID-19 and the scar tissue that may develop inside of the lung or potential lung failure. They worry about organs shutting down. Wouldn't it be cool if in response to a pandemic, an individual's lung fails and we could manufacture them a lung, which you'll hear a little bit about later, and allow them to continue living their normal life? What if there was a world where we didn't have to worry about a transplant list? What if there was a world where we could manufacture some type of tissue or tissue-related technology, be it a cell type or something like that, that would allow us to treat COVID? This is what matters, right? This is what really focuses on, and this is how ARMI BioFab USA, that's focused on the development of tissues and organs, is focused around this effort, right? What can we do to help treat COVID-19? And not just treat it, right? But provide a cure. And, Dr. Doris Taylor said that too in the video. And, I encourage you to go watch that video again. You can definitely find it on our website. We're not treating symptoms anymore. We're curing diseases, and that's really what we hope to accomplish. So we are focused on that large scale manufacturing of tissues and tissue related technologies. So what does that actually look like for us? Well, you probably saw really quickly this video of what we call our tissue foundry. This is an end-to-end manufacturing line that enables the growth of tissue. So in this picture that you see here, these are all of the different components that are needed in order to fuel this. So you can see here, this is a good shot of the foundry line and what it looks like and how it works. But essentially what happens is an individual would put a vial of cells, which you can see a vial of cells here in the bottom left, into the system. And 45 days later, you get a tissue. And that's just mind-blowing, right? For people to not have a say in when things are ready, but have this be a completely automated system will definitely ensure consistency. It will make sure that your products are really, they're meeting all of the right requirements, right? No one wants a defunct lung to be put in their body, right? You have to take into consideration that these products need to be absolutely perfect because you're taking into consideration the life of another human. This picture here, it has an Eppendorf, the blue cap. There's one here, and then there's one over here that shows two. This is our culture system. So I said, you're going to take that vial of cells and you're going to put it in. And what you can kind of see are all of these wires and tubes and probes and things that go in there. And those are super important because those help us understand what the cells are producing. It makes us understand that the cells are healthy. It manages the fluids that are going in and out of the system, and it's telling you when there are enough cells to move forward. Depending on your product that you're manufacturing, tissue, organ, whatever it may be, we often refer to those as tissue engineered medical products or TEMPs. You may need anywhere from millions to billions of cells. So growing that number up, right? You're not going to sit there and individually count a billion cells. We need to make sure that using this system, we understand how many cells are available inside of that vial. We need to make sure that the pH is right. You don't want an acidic or basic environment for your cells. You want to make sure that there's the proper amount of oxygen. You want to make sure that there's not too much carbon dioxide in there because your cells will suffocate. There are a lot of really important things that we need to take into consideration. And what you'll see at the top here, and we spoke a little bit about this, Rockwell Automation is a huge partner of ours and has been essential as we try to move this whole process forward. The automation of this system is so important. So what we've actually done have taken technologies from that already exist, but basically brought them all together and required them to talk to each other so that the bioreactor is talking to the controller and saying, hey, I have enough cells here, I'm good to move forward, and then can do so. So that's kind of how we're making this happen, right? This is really the magic and the behind the scenes work that's happening here. And this is, again, we're not focused on what cell type is the best. We're not focused on what type of tissue we're going to make. We're tissue agnostic. We care about all tissues. What we're really focused on is bringing these companies together so that they can enable the large scale manufacturing of these tissues. So current efforts at ARMI that are helping make this happen. So right now we have technical projects. What we have is individuals that come forward to us that are really leaders in this field. They have specific topic areas that change each project call. So we have requests for people to submit, projects that they would like to work on that they believe will help advance the industry and move it forward. We have these on a biannual basis, and we have individuals from academia, industry, and nonprofit organizations put forward, these great proposals that talk about what they want to develop. Some of the technical projects that we have running right now are working on the integration of systems, the building of bioreactor systems, the building of sensors. There's a lot of different work right now. So there's not just project calls that are working on the development of organs, but we're also focusing on those tissue-related technologies, the sensors, the bioreactors, the media, anything that you might need in order to make this happen is something that we're focusing on with these technical project calls. In addition, we also have these working groups, which address a bunch of different focus areas, I'll call them: technical, regulatory, workforce development, education, business. And what they do is they help organize information. ARMI doesn't believe that it's the expert in any of these things. We really look to our members to provide us with the information on what's the greatest thing that's happening right now. What's the latest and greatest in the sensors field? Are there sensors that already exist out there? We can't do all the research on our own, or it's going to take us way too long in order to make this happen. So we're hoping that by aggregating the community and working together, we'll be able to better identify these technologies and help move the industry and our members forward. So we're really sort of creating an inner champion, right? We're really helping lift our members up, provide them with the connections through these working groups, allowing them to talk with one another to really create these technologies that will be needed. Now, we focus way more on just the manufacture of organs. And while this is important, this one is probably a little bit more relevant to COVID-19. This is in February 2014, and I apologize for my typo. That should say in February of 2020. I don't know where my mind was there, thinking that this was 6 years ago. But in February of 2020, the United States Department of Health and Human Services announced that the nation's first foundry of American biotechnology would be launched in Manchester and led by Dean Kamen's Advanced Regenerative Manufacturing Institute, or ARMI. This was a huge thing that came to us, and it was really quite opportune that this happened in February of 2020 when we were kind of on the verge of a pandemic, because what this organization is hoping to do, that is headed by ARMI, is really relevant to COVID-19. So this quote here is from our executive director, Dean Kamen, from ARMI BioFab USA. And he said, ARMI is excited to announce the HHS ASPR Next Foundry for American Biotechnology, which we call NextFab. An initial focus of NextFab is on the automated, on-demand, and distributed manufacturing of medical therapies, and builds on the success of ARMI BioFab USA's program to advance the scalable, consistent, and cost-effective manufacturing of replacement human tissues and organs. So in a similar way to BioFab USA, and now BioFab USA has been around for 3.5 years, so there's a lot more developments that have happened here. NextFab is really just getting off the ground, but we're really hoping to accomplish the same thing. We're not hoping to build the medical therapies. We're not doing the research that's going to tell us which one is good and which one is bad. We're really trying to help with the automated, on-demand, and distributed manufacturing so that when things become available, we're ready to manufacture them at a large scale. Right? So what does that look like? Potentially, if there is another pandemic, hopefully not, in the next, couple decades, NextFab hopes to be, the automated, on-demand, and distributed manufacturing for the medical therapies that may be produced in response to those, those pandemics or issues or viruses or whatever they may be. So don't think about ARMI as just a manufacturer of organs. We're really so much more than that. Education and career pathways. So this is another thing that I want to touch base on, and I do want to be cognizant of time because I'm running, a little behind. So you may have seen us before, and I know that you guys are all very involved in FIRST. We were actually present at the 2019 FIRST Championships, and we were hoping to go to 2020, but are gearing up and getting ready for 2021. And we actually brought a couple of different hands-on activities. you guys are already really engaged in the STEM field. You guys are very, you're engineers, you're scientists, you're outside the box thinkers. And we just wanted to show you at the first championships that just because you guys are focusing on robots, that's so applicable to what we do. But this field of tissue engineering, regenerative medicine, biomanufacturing is definitely something that you guys could focus on. So what you'll see here is a decellularized porcine heart. What we can do is actually recellularize that with human cells that will enable it to, grow and be transplanted back into the body. We had bioprinters that were available, and students were able to partake in those activities. And this wasn't just for high school students, right? This is for students of all ages. So I love this picture here of this little girl with her cool safety glasses on and doing her science experiment. She's really excited about it. We hope that, through these experiences and these opportunities, you guys see that what you're doing is super important and you're passionate about it. But there's also so many other pathways that you could potentially take here. And I think that's one thing that we try to communicate is that, we don't need just scientists and engineers. That BioFab USA, ARMI, NextFab, whatever you may be interested in, is really for everyone. We hope that kids will take this opportunity to, learn a lot about, the careers that are available and how they may be able to leverage their robotics to help advance this field. So we created a game, and some of you may have partaken in this, heard about it, etc., called Temptation. And the goal was to engage students throughout the country in tissue engineering, regenerative medicine, and future workforce opportunities. So we used examples, and then here's the example of the video that you guys already watched today. We gave a high-level overview of ARMI, what we do, some of the industry partners that are involved, and then we also highlighted some of our members that are, part of the ARMI organization and the career pathways that they offer. So what are the course offerings that are available at specific universities? Well, ASU has a great program in biomedical engineering. So we highlight the different pathways that are available for you to pursue a career in the field of biomanufacturing, be it as an automation specialist, a tissue engineer, whatever it may be, a technician, whatever inspires you and fuels you. We want to make sure that these things are available. This isn't a resource that's fully built out for everyone right now. We hope that this will be available sometime in the near future for you guys to take advantage of. And we will definitely be spreading the word when that becomes available, and hopefully it's a resource you guys will check out. I think that this is my last slide, and this is about the education and career pathways. And, I like to think of myself as a young individual, but having just celebrated my 30th birthday, I feel like that's not really a fair thing for me to do anymore. But this slide really speaks to me because I was a junior in high school and my mom was diagnosed with cancer. And I was like, well, hey, I'm good at science. I'm good at math. I think that the only thing that I could really do is become a doctor, right? And it was easy for me to pursue that pathway. But it's not always that easy for high school students. There's this big looming question of like, well, you finished high school, now what, right? Are you going to go to college? Are you going to go to a trade school? Are you going to enter the military? Are you just going to get a job? Are you going to go to a technical college? And then you have to combine all of those options with the things that interest and inspire you and motivate you and make you want to get out of bed every day. I entered college with a pre-med focus and a pre-med track, and finished up my fourth year of college and realized that I didn't want to be a doctor. I had gone through 4 years of college. I got my degree in biochemistry, and I was like, well, now what? So one of the things that I would really encourage you to do is just do a lot of research and really consider your options, right? There's a huge need for, this was an interesting stat that we got the other day, that for every one engineer that's in a laboratory, we need 7 technicians, at least, maybe up to 20. A technical college where you have those work-based learning opportunities here, like students are showing, or a trade school opportunity, may be a great pathway for you to take. If you want to go to college, you want to go to a 4-year university, absolutely go. But make sure that you are doing something that's going to inspire you. Don't go and get a degree in engineering, but not have any understanding of what a day-to-day life for an engineer is. And I love this picture of this graduate that says like, please hire me, right? This was me, right? I got out, I had my master's in biochemistry, and I was like, well, now what? What do I do? And understand that this is an evolving story. This is something that is going to take a long time. It's going to happen over time. And as a former high school teacher, I would just stress to you guys, talk to as many people as you can, ask as many questions as you can, and do your homework and do your research. Find something that inspires you and makes you passionate, and just ride the wave and enjoy the whole experience, because it's really fun. And I guarantee you that if you follow your gut and do something that inspires you, you'll be really happy. With that, I'm at time. I have a couple minutes for questions, so I'm happy to take those if you guys want. But anyways, thank you guys so much for your time. I really appreciate it. And I hope that I give you guys a good overview of everything that we're doing here at ARMI.
All three of our children just needed a little bit of extra time to develop and to figure out what they wanted to do. When we heard about the community colleges, we realized that this would give an opportunity inexpensively for the kids to figure out what they wanted to do and possibly find themselves, and through the process of finding themselves, do better. And for us, it has been the ultimate success story. Our oldest went to the community colleges and is now a CPA. Our middle son went to the community colleges and is now in medical school. And our youngest graduated from the community colleges and is now at Northeastern University. What the community colleges did for each of these kids was give them a sense of confidence that they can do it, that they can be a success, and the sky's the limit. So there wasn't a more perfect education out there for them.
The experience that I had at Nashua Community College was absolutely amazing. I mean, I even miss it sometimes now because I had such a great time. I made lasting friendships, I made relationships with professors, and I will constantly give back to the community college because of what is done in our community, in other communities across the country, because I think it could benefit students so much.